Okay, so what we're going to be talking about today is the addition, subtraction, and multiplication of polynomials and some general rules that you guys should already know, but it's just going to be a bit of a refresher. So again, it's review. We're going to move relatively quickly through this. By the end of the lesson, you should be able to identify the terms, the coefficients, and the degree of a polynomial. You should be able to add, subtract, and multiply polynomials as well. Okay, so polynomials are a type of algebraic expression that you will often encounter in algebra. You have seen these a million times. You've seen a million polynomials. This is nothing new. Those below are just examples of polynomials. Notice that they are all in descending order, specifically this one, where there are more than one term there. This is a multivariable polynomial, and we'll talk a little bit more about that as well. Okay, so polynomials having one variable are in that general form, and basically what this means is we like them to be in descending order, where that exponent, where that exponent decreases each time until we no longer have one, or it's the smallest it can possibly be. The values out front, that a to the n, right? These values are what we call our coefficients. Okay, so the number that sits in front of the variable itself. Okay, the terms are the entire piece, and they get separated by an addition or subtraction sign. Those are called the terms. All right, so we know about our coefficients. Our terms, our leading coefficient is that value that sits in front of the variable with the largest exponent. Okay. If you're looking for the degree of the polynomial is going to be the largest exponent in the polynomial itself. That's if you're dealing with a single variable polynomial. Okay? And again, descending order decreases from left to right as far as the exponents are concerned. Okay, so identify the terms of the polynomial. Again, the terms are what's separated by the addition and subtraction sign. We do want to make sure we take the sign with it when we express the terms. So our first term is 2x to the 4th. Our second term, negative 7.5 x cubed. Third term is x, and our last term is negative 12. So those should be very simple to differentiate. Okay, find the degree. Sorry about that. I should have a space here. Find the degree of the polynomial. All right, so again, the degree of the polynomial is the largest exponent. So very quick and simple here. The degree for 2x cubed minus 9 is going to be 3. The degree for y squared minus 3 halves plus 5y to the 4th is 4. Now, the reason it's 4 is, remember, we like these in descending order, and it's going to be the largest exponent there is. So if it's easier for you to see, feel free to take it and put it in descending order. Okay? And the degree for the number 7 is 0, because we don't have an exponent on a variable that we're dealing with. We have an exponent of 1, but it's not on our variable. Okay? When a polynomial is in several variables, the degree of the term is the sum of the exponents of the variables in that term. The degree of the polynomial is the degree of the term of the highest degree. Okay, so let's show you what that means. All right, so notice we have two variables, a and b here. So we want the degree of the polynomial. In order to find the degree of the polynomial, we first have to find the degrees of each term. Now remember, it said the sum of the degrees, right? The sum of the exponents. So the degree for this term here is going to be 4, 1 plus 3. Here is going to be 6, and then 0. So the degree of the polynomial is going to be your largest value here. So the degree is 6. We just select the one that's the largest. Okay. Next page, addition and subtraction. We're combining like terms. You guys have been doing this forever. This should be plain and simple. Remember, like terms means same base, same exponent. Okay? All you do is you add the coefficients. 2 plus 5 gives you 7, and we have 7y squared. We do not change the variable or the exponent. Okay, so let's get a little bit harder. This is bigger. Again, we're looking for like terms. X cubed, x squared, x. We want to make sure we match them up. So let's deal with the first one. Negative 5x cubed. We're going to look for another x cubed. And we see it over here, 12x cubed. We're going to combine those by adding. Negative 5 plus 12 is 7x cubed. Go on to the next one, 3x squared and negative 7x squared. Negative 4x squared. And then we have minus x, but no other x over here, so we're going to keep that. And then a plus 3, but no other constant, so we're going to keep that as well. So our sum is 7x cubed minus 4x squared minus x plus 3. Okay, next one. Now this one's a little bit different. We're subtracting polynomials. We have a rule for when we're subtracting polynomials, and I know half of you are jumping up and down right now in your heads saying, keep, change, change, keep, change, change. You're absolutely right, okay? We are going to keep, change, change. What we mean by that, keep the first polynomial. Change subtraction to addition and change all of the signs in each term after that, okay? So our new problem becomes 6x squared y cubed minus 9xy plus a negative 5x squared y cubed plus 4xy. Okay, so we keep, change, change. Now that we've done that, we can combine our like terms. All right, so here's what we're looking for, like terms, right? X squared y cubed. Do we have another? Absolutely. X squared y cubed. Okay, we got to add their coefficients. 6 plus a negative 5 is a 1. X squared y cubed. Then we have an xy. Do we have another one? Sure do. Negative 5xy. Okay. Let's try multiplication. All right, so when we're multiplying, we're going to start with monomials. Monomials are very simple to multiply. You multiply the coefficients, and then you multiply the common bases. And remember, when we multiply variables, we add their exponents. So coefficients, negative 2 and 5. Multiply those, we get negative 10. Variables, add the exponents, x, 3 plus 4. So we get negative 10, x to the 7th power. Remember, you have to absolutely have got to know your exponent rules. Those are going to become increasingly important throughout this year. Okay, so let's try one. We've got 3 and 8. Those are your coefficients. Gives us a value of 24. Y and y cubed. Y to the 4th. Remember, that has an exponent of 1. Z squared, z to the 5th, z to the 7th power. And there you go. 24, y to the 4th, z to the 7th power. Okay, so now let's deal with foiling polynomials other than monomials. Okay, you remember FOIL, first, outer, inner, last. You know how to do this in your sleep. All right, first, x times x, x squared. Outer, x times 3, 3x. Inner, 4 times x, 4x. And last, 4 times 3 is 12. Last step here, combine those center terms, your like terms, and you get x squared plus 7x plus 12. Now remember, you should be writing all of this down, either putting it into your calculator or your notebook. It's up to you, but it does all need to be recorded. If you need to go back, you need to pause the video, please do that. Okay, so let's get a little bit bigger. Now we're multiplying a monomial, or a binomial, 2 terms, and a trinomial, 3 terms, okay? Now this is essentially the same thing. All foiling is distribution, okay? So we're going to distribute this as well. We're going to start with the 2 terms. We're going to distribute those 2 terms through. So there's the first one, and then the second one, okay? You're just distributing all the way through. So we're going to start with that 2y. Okay, so essentially what it looks like is this. 2y, 4x to the fourth y minus 7x squared y plus 3y plus, right, we have to add to that, negative 3x squared y times 4x to the fourth y minus 7x squared y plus 3y. So you're just distributing both pieces. Okay, so let's start with the 2y. 2y times 4x to the fourth y gives you 8x to the fourth y squared. So there's my first term. Negative 14x squared y squared. 6y squared. So there's your first one, right? Now we're going to move on down below to negative 3x squared y. So I'm going to put a plus. Negative 3 times 4 is a negative 12. X to the 6, y squared. Plus 21. X to the fourth, y squared. And minus 9x squared, y squared. So my last step here is to combine like terms if I have any, okay? So I've got x to the fourth y squared, so I'm looking for another x to the fourth y squared. And if you look down here, we do have one. So we're going to combine those together to get 29x to the fourth y squared. I'm going to cross them off so that I know that I've used them. X squared y squared, do I have any more of those? Looks like I do. Negative 14, negative 9 is going to give us 23, negative 23, x squared, y squared. Okay. And then we have these two, but if you look, they don't have any matching pieces. So we're going to put those back in. Now, if you like I do, I like things to be in descending order. And notice that the only variable whose exponent is changing is the x, so we're going to use that to adjust our descending order. Negative 12x to the 6y plus 29x to the fourth y squared. Sorry, I'm using squareds here. My apologies. Minus 23x squared y squared plus 6y squared. Okay, so I know that this is long, but it's not a difficult process. It's just distributing. You guys know how to distribute, so this should be no big deal. Okay. If you need to pause it to get all this down, please do so. All right, so again, here we are. We're going to FOIL. So first, 2x times 3x, 6x squared. Outer, 2x times 4, 8x. Inner, 21x. And last, 28. Combine those like terms. And you have your trinomial. Okay. Let's try another one now. Okay, so all this means, this quantity squared, is that you're going to multiply it by itself. Okay, so 4x plus 1, 4x plus 1. Again, now you're just going to go ahead and FOIL. 16x squared plus 4x plus 4x plus 1. Combine those like terms, and you have your trinomial. Okay? All right, let's try one more. And again, we're just FOILing this out. X squared times x squared is x to the fourth minus 3x squared y plus 3x squared y minus 9y squared. Combine your like terms. These centers cancel. And you're left with x to the fourth minus 9y squared. Okay, great. So make sure all of your notes are complete. You come into class with any questions, and I will see you all tomorrow. Thanks.